Testing, 1, 2, 3. Hi, good morning. I hope you still have not sleepy. Pretty sleepy on the train, so I slept, so it's much better for me now. So the first thing I want to say is because we have homework 3 is due, so we have homework 4. Again, it's 2 weeks. So you'll cover the sampling, distribution, estimation, and that would be the we'll close this door against this door first. So this is something very much standard to us. So I don't see I need to go over, but you will see the question are really straightforward. So just the purpose of this homework, just make sure that you read your slides. Okay. So basically, all the questions should be able to answer that from your own slide. So as many of you have asked, and some of you are worried about the project. Okay. So I want to say the project, I didn't announce it because to me, that is the last homework. Although it's named project, but it's a long homework. It's rather than open-end question where I ask you to do this, to do that, to do this, to do that. You are basically doing on your own. You figure out what is a topic, what data you want to find, what analysis you want to do. Okay. So let me go over this document with you. This is already in the Blackboard. So basically, I just try to have this project to apply to some actual problem. It's an open-ended assignment. And the deadline will be, I think, is the after the end of the 13th week. Okay. So you can do it on your own, or you can do it in your group. Okay. And of course, you want to do it in a group because of the question you're doing is big, so that you want to combine other people's strength. And because you can submit on your own, I'm not going to get into what happened in your group, where there's free rider or what. Okay, you just, if you think that free rider, exclude them from your list. Okay, you don't need to tell me your group. Okay, good morning. So at most, I think it should be 6. Okay, if you need to have more than 6, let me know. But I think at most you should have no more than 6 people. Okay, otherwise, if the whole class submit one project, then probably is defeating the purpose. So I think 6 would be the maximum number I should allow. I mean, unless you say you're doing very big project, then probably I will talk to me if you need more than 6. And as I said, I assume there's no free riding. If there's free riding, you should drop him out. I mean, more or less, okay. And if you submit in the group, then I assume you just everyone contribute equally, okay. So the main thing is I want you to write a written report to report your finding, okay? And later I will talk what is your report, but talk about the your delivery, your deliverable will be the, if you are one guy only, one person, you just need one A4 paper, okay? Two sides, okay? If you're two people in your group, you have two A4 paper, okay? That is the maximum, okay? So you can have less than the number required, but what I mean is if you beyond the page limit, I will not read it, and also your marks will be deducted. Okay, make sure that you strictly follow your page limits. Okay, and at the end, I want you to submit a PDF form. So already, where standard thing. I think you've been doing this in your homework. So how you should proceed with the homework? Proceed with the project. So basically, you want to discuss what topic to work on, explain very briefly why it's interesting. Okay. To give example, maybe you want to work on, I don't know, you want to know, say something like now when people want to take Sinovac or the I don't know, Pfizer, right? By BioNTech, right? So you want to compare the two, right? You want to see is young people more likely to take BioNTech or old people more likely to take BioNTech? Those, I mean, by age or by gender, right? Or you want to see the vaccination rate, is it different by gender, different by age, different by I don't know, this kind of question, right? You have to explain why it's interesting, right? Or is more younger people willing to take a vaccine, or older people willing to take vaccine? Or do they think effective or not? So this is kind of some kind of example of question you want to ask. Or you want to say another example, maybe you want to say, oh, is people with high DSE, right? Will be doing better in DSME, right? For example, or doing a better GPA, right? And then having better DSE grades, is it going to predict you better better job prospect? I don't know. I mean, there is some, or is it more people with higher GPA is concentrated in some kind of college? So there are many questions you can ask, and you can verify by data. So you explain why interesting, right? And that's why you want to study it. And then you look at your data, right? Either you can use the data using descriptive statistics, using table or graphics to describe data, okay? And how to collect your data? You can collect your data from internet source, right? The secondhand data. Or you can collect your own data, right? You can just ask your friend to fill in a survey and put it on your Facebook or IG, ask people to fill in. That's also fine, okay? And I don't care how you do it, but if you do it on your own, you just describe more detail. Later I see in the appendix, okay? And the main focus of report, I mean, besides to present the data, of course, you want to analyze it. That's the main goal of this, right? You really want to tell how to do an hypothesis testing. This we'll do today. And we will do some estimation, right? You do some prediction, okay? And we will be using some regression and ANOVA, okay? That's why I'm not talking about this homework until this late, because you will not really sure what you're going to do. But you have some idea what kind of question at this point. You know, estimation, probably you have some idea, right? You want to see, okay, how many people like, one of the puzzling to me, to some of my friends at my age is like, okay, I saw many people like Mura. I don't know how many people here like Mura, but I never have any friends have developed this kind of affection towards this group. But you may try to use data to see, okay, actually there's many people like this kind of group, but this is also one of the questions that say interesting. And then how your grades being determined, right? Because this is a more like open-end assignment, right? So you will be depend on how you choose the topic, whether you do it correctly, and how you present your result, right? There's three aspects. I hope you would because we're B school, right? I hope that you would try to make your report look more professional, okay? Just try to use some color, try to use, if you use graphic, make sure that you don't have a very blurry one, okay? Make sure that your font looks professional, okay? How to look professional, just pick up any report and see how people make it professional, okay? I'm not going to give you an exact guideline what to do, but this is, I hope this, at the very last assignment, hope you can summarize all the skills you learn. You don't have to use all the skills. Of course, depend on what question you want to ask, right? If you want to ask the proportion thing, then you probably don't need regression, right? The ANOVA is the thing you go at the end, okay? So it really depends on what kind of question you want to ask, but that would be the end goal. And you would have several appendices, although you just submit one page, but you need to support your thing, your report. So the first thing you have to have a team member appendix, because probably in the paper only one page, right? Then you probably don't have the place to write who you are, right? Probably you have the appendix to list who you are and who are the ID or what, I mean, or any comment you want to like, or anyone you want to thank, whatever. And there's a second appendix, data appendix, right? If you collect from data source, you describe how you get it and how you clean it up, or where you get those data, okay? Or you are going to collect it from your own way, you have to describe how you do it, right? Suppose you just, in the old days, I don't know now, but in the old days, how you do survey, you go to library and just give people a paper and fill in. I mean, I don't know how we're doing these days, but I guess there are not many people in the library. So probably you would just send it to somewhere, I don't know, there's a forum or whatever, just ask people to fill in. I mean, that would be fine. Or if you want to, want me to, maybe I can open a forum for our class if you want to send it to our own classmate, you want to ask some question, also fine, that would be also okay. And at the end, I want a technical appendix, okay? If that tell some steps behind your calculations, okay? And also include your R file if you want to, okay? So that would be the, it's just a longer assignment, okay? Just, but I want you to do it more professionally, okay? So that is the goal of this assignment. Is it any question? So it's still too early, but since people are worried about it, I have heard from some of you, so I just want to say it earlier. But of course, it's still not clear because I haven't teach everything yet. But I hope you know what you're doing. You are just basically you are thinking about a question related to statistics with this class. Okay, try to think about what data you want to get, and then you try to conduct analysis on those. Okay. And then at the end, you just submit your report, and then because I don't want you to overwork, so I put the maximum page limit. So make sure you don't overwork. Okay. So just at most, if you do it by yourself, it's only 1 A4 paper, 2 page. Okay. So don't overwork on that. I mean, because I know every of us are busy, so I try to make sure that you don't spend too much time on it. I mean, you spend some time, but I don't want you to spend too much time on that. Okay. After this, you're able to learn how to use all the Excel R or all the technique you combine here. Okay. Any question? But you don't have to worry about it yet because I don't think but you can start thinking about the question if you want to do it in group or do it in your own, also think about the question. Okay. Any question? Any question? Is it okay? I mean, shouldn't be if you in this class last year, you'll be more intensive. So this year, I think we'll have more relaxed project. So last year we have presentation and all the stuff, but this year make it easier because I think I don't want to put too much burden on you. So just make everything simpler. Okay? There's no presentation for this. Or I'm supposed to do some presentation, but I guess it's the COVID, everyone having the mask on, and doesn't seems to be very comfortable. But anyway, if you really want some presentation, let me know. But I guess our time is more limited, so I guess that should be okay. Okay, any question? If there's no question, then maybe let's go ahead. Just to remind those who arrive late, we have homework 4 is going to be, you have almost like 10 days to do it, more than 10 days to do it. And for the project, it's going to be the end of the semester, so you have like 40 days to do it. But as I said, you don't need to work very much about it because there's some of tools we haven't finished. So basically, you're probably thinking about what kind of question you want to do at the moment if you really want to think about it, but shouldn't be a big problem. And today I'm going to talk about hypothesis testing. After this, you will probably know more skills because basically statistical analysis is divided into 2 different parts. The first part is estimation, which we have covered already. Okay, we know the 2 types of estimation. You learn there's a point estimation. You try to guess a sample mean, right? That is the sample proportion, and this is the main goal. And then you can keep in your mind when you look for the project, right? Try to estimate as the mean, right? Maybe mean income, or the mean GPA, or mean time spending on this class, or whatever, right? Or whatever thing you think is interesting to you. And the second thing is besides estimation is called hypothesis testing. Okay, so basically there are 2 things in statistics. Using a data, how to do analysis, estimation and hypothesis testing. And after that, we have 2 more topics, right? We have ANOVA and also regression. And those 2 are basically also, you can see it's a more detailed look. You give the data more structure, you get special data. We're also doing estimation and hypothesis testing. Okay, so basically these hypothesis and estimation is the basic thing. And when you go to ANOVA, it basically talk about special model. We can talk about how 2 categorical data are related to each other, right? Or 2 categorical versus numerical data, right? And we also have the tools talk about 2 numerical data, right? How income is related to education, right? This kind of problem. And I hope after this class you understand what's going on here. So what is hypothesis testing? So maybe let me start from a relatively simple question. Okay, actually it's also historical related idea is almost a story. And the story is the following. I think if I remember correctly, there's a famous statistician called Fisher, Irving Fisher, I think in 1900s ago. Okay, and the problem is like he has a colleague, okay, a lady who claim, okay, I know everyone knows coffee, right? And coffee, you have coffee and milk, okay, and you put water in the coffee, right? And then or steam it, whatever, and then you add milk, right? There's some way to do it, or the other way is add milk first and then you add coffee, right? And the lady, she claimed that she know if you give her a coffee, she can distinguish whether milk is added into coffee first or after. Okay, I don't know whether you can distinguish, but this is real historical event. Okay, it's not something I make it up. Okay, you can look at Wikipedia, call Fisher exact test. This is a story. Okay, so the question is how to test this claim. Okay, so I give you, then you're going to test that lady whether drink the coffee and see whether the milk first or coffee first, right? So coffee bean first or the milk first. And of course, if you give a coffee to her and which is milk first, suppose, okay, and she say coffee first, then you know she do not have the special ability, right? One negative test, right? Basically, you will say, okay, probably she don't have the skills, right? So, but if the first time she got it right, okay, you may say, okay, maybe, but she may be just guessing, right? Because it's only either milk first or coffee first, right? One way or the other, just half and half, right? Even you don't know, like me, I can't distinguish. I still can be right half of chance, right? Just by simply guessing. Okay. So what we're going to do, right? In the real world, we're going to do, right? Just give her another cup of coffee. Okay. Of course, you don't know whether it's milk first or coffee first. Ask her again. Okay. And she's okay. If she got it wrong, then okay, so maybe she's just guessing. Okay, just bye-bye. And I don't believe her, right? But she get it right again. Okay. Then that is not easy, right? If you get two correct, what's the probability, right? Is first time you get it right is 1/2. Second time you get it right is also 1/2, right? So the good both of the right is the union of the two, right? And is independent, so multiply, right? A and B, right? Is independent, right? Because I just randomly give her the coffee, right? So then it means that she get it all right in 2, the probability is 1/4, right? So it's still okay. Maybe it happened, right? 1/4, you still okay? I don't that believe. Okay, let's try again. Okay, if she failed to distinguish, then okay, you don't believe it, right? But she did again. Okay, so then the probability by luck, okay, is 1/2 times 1/2 times 1/2, right? That means it's 1/8, right? That is like more like 10%, right? You think still 10% maybe if you are more relaxing 10% around, then you say okay, right? But if you still okay, no, this is not enough. Give her one more, okay? Give her one more. Then what you get, okay, is by chance you can get it right. Is how much? It's 1/16, right? So it's like, well, it's like more like 5%. Okay, slightly more than 5%. Okay, you may say, okay, no, not really. I still don't really believe. Right? How then you ask, okay, how much you can believe? Okay, so usually we would do like more like 5 times, right? You more like the 5% rule, right? Then we will say after she get 5 or 6, right? 6 consecutive correct. Then you will think luck should not be the element there. Okay, so let me show you the Excel. Probably you will be easy to see the numbers. So let's see the numbers in action. So how to get the first time correct by luck? Simply by luck. Let's see. Okay. Why am I? Oh. It's not responding. So first time is 0.5, right? Second time, 4 times, okay? So basically it's 0.5 raised to the power this guy, okay? So you can see if the lady get it right the first time, it's by luck half of the chance. If you get it right by chance, it's only 25%. And if luck by chance is 12%, right? And this is only 6%, it's less than 5%, okay? And go on and go on. If you want 1%, you need to go lower, right? So you would think if she got it right 5 times, okay? If you think 5% of luck is unlikely, okay? So you say alpha is 5%, okay? That is 5% unlikely. Then you would be thinking, okay, you get 5 times right, then you believe you have some special ability, right? So that would be the rule, right? So what here we are doing is a hypothesis testing, right? We assume we are going to see whether the lady has a special skills. Okay, how to do it? Use the data. Okay, and use the data to see whether what is being tested is likely or not. Okay, what we're doing is we suppose she is purely guessing. Okay, is it purely guessing? Random by luck is half the time, right? Is it half the time that you will be? Because I don't think I mean, it's a very general. We assume that no one has special ability, right? Very special, and then we'll try to see if our data is rejecting or refute this claim of she has special ability. Okay, and how to do it if she can't distinguish, right? The rule is here is if she can't distinguish, basically you will say she don't have ability, right? But here you say I would willing to say if 5% of time, right, is by luck, then we say okay, she may has ability, right? So if you have 1, then you say no, but 5 or more, then you say okay, it's very unlikely you get it through by guessing. So she may have some ability there. So at least she may not be 100% no, but at least you would say she is better than guessing, right? The blind test, right? So that is a special way, right? And actually, that's how people try to say whether they have good taste, right? I mean, you have two bottles of wine, right? And one is expensive wine, one is a cheap wine, right? I mean, then you want to see how people taste, whether they have good taste is whether they can feel that the more expensive wine actually has you know it is expensive, right? Actually, there's a lot of blind tests, right, on say mooncake, right? They look very, very fancy, but they may not be taste good, right? So that's in a way. So that's the one of the idea behind the hypothesis is we have something we want to test, use the data, okay, and based on whether it's luck or not, we come out with some probability and look at data, okay? If the data would suggest you that the likelihood or the probability that this thing would happen by luck, simply chance, is so small, right? Like the rule would be if you have 5 of them is correct, they'll think, okay, it's unlikely to be by just guessing, right? Then you would think you believe her have some special ability, okay? So this will be the goal today. Of course, this is just example. The goal would be like the following. Later, we will see if I want to see what an example that we are doing is quality control problem. Okay, so you want to say someone want to claim say your mobile phone service, right? Will be saying you say using 5G. Okay, 5G means certain speed limit, right? Speed bandwidth. And you want to claim, then someone claim this gives you the 5G is very fast, right? Then you want to see whether the claim is true or not, right? Based on the data, right? Whether it's real 5G or the fake 5G, right? Or the other example is you want to buy a bag of rice, which is say 5 kg. You want to see whether this is actually 5 kg or not 5 kg. If you are quality control, you want to make sure that it's not more than or less than, right? Because you don't want to be cheating, right? Or being sued by cheating. Or if you are consumer counsel, with the government, you don't worry about if more than 5, but you care about less than 5, right? Or if you are a health department, okay, then probably you worry about whether the food contains too many harmful substances or not. Okay, or you are the environmental department, you worry about whether the water is clean or not clean, right? Or the other way around would be, that would be a good example, maybe typhoon signal number 8, okay? And you know in Hong Kong, I mean, they have typhoon signal when the wind speed is higher than a certain amount, right? And it is easy to see it's a typhoon number 8 if every station doing the measurement above that limit, right? But it is not this case, right? Sometimes it's just like half of them, maybe say 30% of them, right? Not all of them do it. but the observatory may still decide whether to go ahead or not, right? So that involves some hypothesis testing idea here. But anyway, let's go directly, and then you will see how we are going to do that. Okay. So for hypothesis testing, we will divide our study into two parts. One is called one sample. The other, of course, will be doing two samples. One sample means we have one object of study, one group of study. We want to see whether the sample mean are basically equal to that number, or sample proportion equal to that number. The example we said is whether the lady has special ability is whether she can guess correctly more than Ph.D. guess, right? More than 50%. Okay, just a one thing. And probably next class, basically we will talk about two samples, which means that usually we compare two groups. Whereas we said at the beginning, we want to compare, say, people taking, say, look at the antibody, right? Taking the vaccine or antibody. You want to say, is people taking one type of vaccine has more antibody than the other one, or the same, right? So you compare two groups of people, right? And two groups of the mean. And also you can compare two types of proportion, right? Say if you want to say, oh, maybe CC College have more, someone claim maybe CC College have more women, more lady than say NA College, okay? Then you will have two proportion data, right? And you can compare, right? So that is the idea. But we focus on one sample, which means that we'll focus on one simple problem. But later you will see next week, the tool will be very similar tools, okay? We just make different assumptions, and then that's how we do the analysis. So let's get started, okay? So sorry, we have to have some terminology before we can go, but you will see the idea is not very difficult, okay? So, and these actually for hypothesis testing, there are two types of hypothesis. One is called null, the other is alternative, okay? Null is something usually we have, okay? We want to test it. This is something a working hypothesis at the moment. We want to see if we are trying, the aim is trying to reject it, okay? It's not we like it, but it's something that if we're happy with it, we don't do data, right? We don't need to collect data. It's saying the data actually is not, you're thinking the data is not supporting it. You're trying to get out, okay? So look, remember the example of the call fee first and meal first example, right? You want to try to see if the lady have a special ability, okay? The null will be, she has no ability, she's purely guessing, right? Or then we'll say she only have the chance of getting right is half, right? And then you want to test the alternative will be more than half, right? If she is worse than the random guess, then she's worse, right? But we really want to see is better than that, okay? This alternative. Okay, go back to the rice or milk example, product example. You want to say the null will be someone, you are doing quality control on the rice or bread, it's a 5 kg rice. The null will be, you want to test is 5 kg, right? It is 5 kg. The population mean is 5 kg. And the alternative will be, it is not equal to 5 kg, right? Or more or less. I mean, it depends on how you define, but you will see the alternative and the null are mutually exclusive, okay? They're not exhaustive, but must be mutually exclusive, right? So you want to see whether the null is correct. So the overall idea is we will assume the null is correct, okay? And we will, based on the null is correct, we can derive the distribution of sample mean, okay? You talk about sample mean or sample proportion, and look at the data, okay? And see how likely the data is being arise, okay? If the data is really like a luck, okay, then you will say, okay, I don't think what we should believe what the null, okay? If it is, we can't rule out that, then yeah, that's fine, okay? So we'll be more clear on this, but the logic is very simple. It just basically like this question. Let me see if I can write here. There's no pen. I hope it's something you see here. So it's basically this what we will do is by central limit theorem, the sample mean it looks like a bell shape. Okay. Suppose you are quality control, right? For the rice manufacturer, a 5 kg bread bag, right? So I don't know whether your parents still cook, or you still cook, but this is the common thing you see in Hong Kong, right? 5 kg bread. The quality control, you want to see this 5 kg rice is going to be a right thing, right? So you want to assume the null is right. So the you think this 5 kg is here, right? You assume this is right, okay? If what they claim is right, okay? Then this will be what you should expect to see. Okay? If this is what you expect to see, then you should expect that the sample mean would be mainly concentrated on the middle, right? It's very unlikely to be on both sides, right? If it can be both sides, can only due to luck, right? If there's somewhere here, it's so far away, okay? It's far away from the middle, okay? Then you would try to say this is unlikely, right? If it came is sample mean, the population mean is 5. If it is too far away from that, okay, that is unlikely. Okay. The question is how to define far away. Okay. How to define far away? Can you see in the top? So how to define far away will be based on the idea of probability. Okay. Of course, I will give you more detail, but this is just a preview of what we're doing. So we're trying to say the middle part, same as estimation, is 1 minus alpha. Alpha is being a small number. Okay. Say maybe alpha is 0.055%. So the middle is 95. Okay. The two side is 2.5%. Okay, or alpha over 2. Okay. So if it is in terms of probability, this is very small probability. Okay. Then you will think that it's unlikely. Okay, because it's too far away. Do remember that how this probability has been determined, right? If depend on this variance, right? Which is the variance of this guy. Variance of this. Okay. So which means that if you collect more data and it's bigger, then this area will shrink. Okay, this area will shrink because it's more data will concentrate, is more concentrated. Right. So if you have more data, then the extreme is closer for this extreme area. That's what you learn from the estimation, anyway. But there we go. Okay. So just to maybe we'll go into detail how this procedure is being done very soon, probably after the break. But what we are trying to show you is this is the general procedure for what we're doing today. Okay. It will be someone give you, or based on the job nature or based on the problem, you have some hypothesis, okay? And based on the hypothesis, you can construct the sample, how sample mean looks like, okay? Look at the data, see whether it is within this highly likely area, 95% or 90% or 99%. And if it happen to be with extreme values, okay, then you would think
oh, I don't believe 5 kg is the right thing. Okay, so that's the main goal of today. So that is a very simple idea, just to say whether your data is likely given your assumption. Okay. So as we said, we have null hypothesis and alternate hypothesis. Okay, and they're the two types. And but hypothesis itself, okay, whether it's null or alternative, the other way to classify them is called simple or composite. Okay, so for our class, basically you do simple. Okay, simple means that it's like point estimator. You just assume what the sample, the population mean is exactly what value. Okay, it's whether mu is 5, mu is 6 kg, mu is 7 kg in terms of the rise example. Okay, it's just one single number. Okay, and composite hypothesis is rather instead of one number, you say group interval number. Okay, say it's more than 3 or more than or equal to 3. Okay, because more than 3 or more than 3 is like a bunch of numbers, a lot of numbers, right? So that is a composite. Okay, and or not equal to is also a mu not equal to 3 is also a composite because it's more than one value. Okay, so for our class, okay, and basically all the elementary text too is the null hypothesis. It's always simple. Okay, the reason why is we can construct the distribution model easily. Only simple we can create easily. Okay, and our alternative hypothesis is always composite. Okay, so you may ask, can we swap it, make a composite null and then a simple alternative? Yeah, but this is beyond what we should do. Okay, you can do it if you go to advanced classes, but we are just focusing on simple, but you will see this already very useful one. Okay, so that is the way we do. Okay, so as we said, null is always simple. Okay, the alternative can be composite, and composite in many different ways. Okay, and what we are doing is whether we are doing a two-sided one or one-sided. Okay, so just to remind you, null hypothesis is always simple, just one number. Alternative can be two different ways, two-sided or one-sided. Okay, so for the example here I gave on the whiteboard, this is a two-sided alternative. Okay, because I suppose I'm the manufacturer. Okay, I will not be very happy if I have less than 5, right? Because less than 5, then I may be sued by government, right? If I'm more than 5, then I'm wasting my money, right? Because I'm putting too much rice in the bed. Okay, so this is the two-sided one. Okay, that is the first one. I would not be happy if not equal to 5 in this example. Okay? And a one-sided one means that you really don't want something to be too big. Only too big will be a concern, or too small will be a concern. Okay, so if, say, for example, you talk about consumer council, okay, consumer body group would not care if you put more than 5 kg, right? If you put more than 5 kg, the custom would not really care. Okay, no one care. You put more than what you're supposed to put, fine. I mean, they're happy. Only if you would think there's a problem if it is have less than what they claim. Okay, so then it's a one-sided. Okay, it's on the left-hand side. Okay, and when you only care about right-hand side, okay, is you talk about a Department of Health or food safety, right? You think about, okay, how much impurity or how much pesticider or harmful substance in the rice. Okay, if it's too little, you don't really worry. Okay, you worry it is above the limit imposed by law, right? If less than that, the guy is still legal, you don't have to take action. If more than that, you would jump up. Okay, so how to determine the alternative hypothesis depend on what's the purpose. Okay, and of course, if you don't have anything special, it is two-sided, right? Both ways you jump up. But if you have some special reason, you would only focus on one way or the other, depend on application. Okay, that would be the goal. Okay, remember whether it's a two-sided or one-sided, and if what left and right really depends on application. Okay, because you are using a data. Remember, you're using a data to see what the claim is, right? And where you want to support one way or the other as alternative depends on application. Okay. So now before we have a break, let's finish these two slides. I think that's an important thing. So again, terminology here. Okay. When you make a statistical decision, there must be some error. If you're able to collect all the data you want, right, then you don't have this problem, right? But suppose it's the rice problem. If you're able to check every single batch that produced from the factory, then you don't need to make this decision. You just have the data, then you see whether bigger than 5, less than 5 on average at the time, right? You don't have any problem. But the problem is you are not going to do a survey, the census to all single thing. You only to get some sample. Okay, that's why you get some sample. There will be sampling error. Okay, when you make decision based on sample, you must make a mistake, right? And you should. There are two mistakes there, right? The thing is, remember what we are doing hypothesizing is assume the null hypothesis is correct. They try to reject it. Okay. So the question is, the first is because you're doing sample, you may actually reject it even it's true. Look at this example. Okay, even though this is true, okay, you look like this. Okay, it is possible that you, by chance, by luck, actually by luck, you end up here or end up here. Okay, even though this is right. Okay, so that's why we say the reject. Even this is right. Okay, we also reject it. Okay. And this is, we call this alpha, okay? Luckily, the alpha is we can decide the size, right? Because this is the fractal whether we want luck element to be there, okay? And we can say 5%, 1%, 10% is our choice, okay? For the text we consider is a choice. Alpha is the choice of us, okay? We can decide how big it is, okay? Of course, there's no free lunch, right? Since I said alpha, you can choose, right? Why don't we choose the as low as possible, right? We make a very big alpha. So yeah, we can make as alpha as small as possible, right? We can make it go to 0, right? And as you can see from here already, if alpha is very small, what does that mean? This, when alpha is very small, this push all the way down and this push all the way up, okay? And if you alpha like so small, you never reject things, right? What does that mean? If you never reject things, what's the problem? You will be a type 2 error, right? Because if you make it so big, the alpha, right? That means that based on this rule, even it's not 5 kg, even it's 4 kg or 6 kg, you don't reject because you push it so far away that you're never able to reject things, right? So that's why actually the type 1 error or type 2 error are trade-off. Okay, there's no free lunch. If you want a lower alpha, you must have higher beta. If you want lower beta, you must have high alpha. Okay, so although we don't explicitly calculate beta, okay, in our class, okay, but there are two trade-offs. Okay, having high alpha has low beta. Having low beta means high alpha. Okay, for the thing we're considering. Okay. And you may ask, okay, so with the choose, is there any way to reduce both? The answer is yes. How to reduce alpha and beta? Simple. Collect more data, increase n, then you can solve the problem. Okay. So that's why that's how science goes, right? When science, some people do in small sample, right? And you still think maybe a problem, right? So you do a more sample and more sample is done. That's how the vaccine is being done, right? The phase 1, phase 2, phase 3, and then go, right? So this is exactly what it's doing is you would increase the sample size to make sure that alpha and beta are very small, then you're happy. Okay, just to recap, alpha is the type of error although the null is right, this is rejected by chance. This alpha we usually can control directly, right? And this is called type 1 error. The type 2 error will be if the null is wrong, it's not actually 5, okay? But it can be wrong in many ways, but maybe here or there, but it's wrong, but you can't really reject it, okay? So that is the beta. And we'll define 1 minus alpha is confidence level, which is same as what we learned in the estimation. And 1 minus beta is called power of test, okay? So let me finish the final slide on this page and then break. Actually, we've discussed this, but just let you see the table. So actually, there are 4 situations. If null is true, you shouldn't reject it. The probability is 1 minus alpha. If you should reject with alpha, right? If it is false, okay, you do not reject with beta. That is type 1 error, type 2 error, and 1 minus this will be the you are doing the right thing. But do we know which one is which? We don't know, okay? Because we don't know X null is true or X null is false. So we have no idea which column we are in, okay? But of course, we are trying to hope that we try to make alpha and beta small, okay? And as I said, that's trade-off. The only thing can reduce both of them is try to increase the sample size, okay? And how to calculate beta is relatively hard. We don't talk about that here, but you can but I can assure you that holding the sample size constant, increase alpha, will reduce beta. Reduce alpha will increase beta. Actually, you can see from here, right? Technically, is if it's not 5, right, it will be something else, right? And something else, you can see the area, okay? If you increase alpha, right, you are unable to reject the right thing, okay? But anyway, just before break, just to mention the alpha, the common value you will see alpha is 10% is 0.1, 5% 0.05, and 1% 0.01, okay? And you may ask which one to pick. Indeed, you don't pick. Of course, in the exam, you may only ask one question, ask by one. But in reality, people do 3 of them together. Okay, so you would be asked. People would expect you to do 3 of them. Okay, and by default, you know, if it is another, if your test is going to be good at 1%, okay, it's also good at 5%. If good 5%, also good at 10%. Okay, but not other way around. Okay, so you usually report the lowest level. Okay, so the reason is if you have alpha that is getting smaller, right? So if you reject with a good percentage or higher percentage, also you reject a lower percentage, also reject higher percentage. Okay, but anyway, let's have a break of 10 minutes, and then we come back. We will talk about how to do this exactly. I guess we should resume. So before the break, we talk about null hypothesis, alternative hypothesis, right? And the two main things, right? And also the other classification of hypothesis is a simple hypothesis, which we'll be using for the null. And there'll be alternative hypothesis, composite hypothesis will be applying to the alternative. And for the composite hypothesis, either you have one-sided or two-sided. Okay. And after that, we learn terminology we call the type 1 error and type 2 error. And you know that the two are basically the trade-off. If you want a smaller alpha, then you have bigger beta, and vice versa. And we basically give you because we're talking about sample mean, but basically this is the graph we're using for the rest of the class. So the procedure is involved, actually, we have here already. Okay. So first, you need to state what is your null hypothesis and alternative hypothesis, right? In this case, let's do it once here. For example, to show the idea, you will say H null mu is 5. Okay, we want to say mu is 5 here. And alternative, okay, consider case we only be concerned with our rise is more than 5 or less than, is whether equal to 5 or not, right? So we use a two-sided alternative. Mu is not equal to 5. Okay. The three choices are this, or this. I mean, you can use one of the three, but which one to pick depends on what you think there will be a dire consequence. Okay. And this is the first part. And the second part we are doing, right, is based on a test statistic. In this case, we are testing based on X bar, right? We are comparing the X bar, okay, whether it is a very low number, a very high number, right? So the rule is if the rule, the following, if this is bigger than a big number here or less than a small number, if either is true, then you will reject. Okay. And how do you decide this number, right? This number come from here, right? This M bar is the place where this is R/2, right? And M lower bar, and this is the place where, okay? So that would be, how do we do it? Okay, so that would be the compare number 3. We compare where this number, okay, where your X bar is within above this region or this region, right? And that sometimes we call this region, we call rejection region. I didn't put the name in the slide, but this is sometimes the book would put rejection region. Okay. So you would decide whether your X bar is in the rejection region or the other way around. This is the one way. The other way around is alternatively. You look at the following. Okay. You want to instead of looking at the upper M, right? The other way around is look at your data, X bar, okay? Look at the area. Okay. If this area we call P, okay? P is less than, okay? alpha over 2. Okay. Then you would be saying it's too far away, you will reject. Okay. So that's the main idea. So don't worry about it, just give you the idea. Okay. I do it very loosely. We talk about more concrete. Okay. But this is the main idea. Okay.
So let's see the procedure. Okay.
First is whether we know sigma, like estimation. If we know sigma, then we use the result set text. If I don't know, which is usually the case, we don't know, it's just t-test. Okay. Do remind you that z and the t are very similar when n is big enough. Okay. And big is like more than 100. There's not much difference when you do z or t. But anyway, keep in your mind they are different only because whether you know sigma or not. Okay. So let's talk about the let's do the one-sided z test. You will see the left-hand side will be same, and two-sided will be similar. Okay. So let's do the first thing, right tail test. Okay. Right tail test is the null is always simple, so you can see the null hypothesis is whether the population mean equal to some number a. A is a number. In this case, it's 5 in my example. Okay. And you want to see the alternative is more than A. Okay. So you can imagine this is the harmful substance, right? When it's more than this, then you will say, okay, we have to be careful. The manufacturer may have violation rules. Okay. And how do we do the test statistics, right? How to test the population mean equal to a certain number? Okay. How do you test it? The answer is very simple, because remember what is a good point estimator for population mean? From last class, we know is sample mean. Okay. Then we want to know how sample mean is it, right? And actually we learn based on central limit theorem. Okay. If you claim mu is A, so this is A here. Okay. And what actually you're doing is look at, if you assume A is true, right? By central limit theorem, it will be x bar minus mu, which is A here, over the sigma over root n will be a standard normal. Okay. So instead of looking at the z, okay, and we're looking at the x bar, we're looking at A. So let me write it here. So what we are doing is we're doing z thing. This is 0. Okay. So what we're doing is this A will go to 0. Okay. How do you do that? Is this transform? This is the standardization, right? This guy is called Z, right? Because this is normal 0, 1, right? Normal distribution with mean 0, variance 1. Okay. So again, what we are doing here is, what we are trying to do is the following. What we are doing, so we have this bell shape. Okay. We look at the data. Okay. And remember, this is we decide what is 1 minus alpha here. Okay. And the question is, we're trying to look at the data. The data is, say, I don't know, somewhere here x bar. Okay. And we want to also transform this to this. Right? How to do that? Exactly by this formula. Right? X bar is a certain number there. We move it to here. Okay, by this formula. And then remember, I want to look at this area. So in our example now, in our example, so we are doing one tail test, So we are saying we claim this is, say, 5 kg. We would be not happy if this is too large, okay? So we will be basically talking about this. We want the log to be here, alpha. Okay, so everything on the left-hand side is 1 minus alpha. Okay, so this means that the tail area is 0.05. Okay, and as we see here, we want to find this number. Okay, or we can transform everything into this thing, right? Okay, if you transform this to this one, alpha, right? This will be Z alpha. All right. Z alpha is what in Excel will be just norm dot S inverse alpha. All right. So this number, okay, and that means that the following: if your data, okay, is, I don't know, is somewhere here, okay, the transformed one will also be here, right? Because the same thing, right? The relative thing remain unchanged. If it is within the blue region, right? This is the rejection area, right? Rejection area. Okay. Rejection region. Okay. This is also the rejection region. Okay. If it is within here, you'll be within here, right? If outside the region, it's also outside the region. Okay. So basically, what you're checking is you're checking this number. Okay. After, depend on what you calculate, whether this number we call the test statistics. Okay. Whether this is greater than Z alpha or not. Okay. If greater than Z alpha, then you reject. If less than that, you don't. So that is what is written here. Look at the Z alpha table, which is actually looking at this one. Norm S dot inward alpha. And if your number is more extreme than that value, which we call Z alpha, called the critical value, also a name for that. Sorry for a lot of names, but this is the terminology people use. I just have to introduce to you critical value. Okay, and if the test statistics is bigger than the critical value, okay, then you reject. Okay, the other way around is to do the alternative is you try to look at this value, suppose sample mean, convert to here. Okay, and you want to calculate this area, which we call p-value, right? And then if this p-value is less than alpha, they also reject, right? Because how luck is, so the luck is less than 5%, then you reject. Okay, don't worry, we'll give you an example, then you can follow. Okay, so this is just an overall idea. So let's see the example here. Now the first part is you're given sigma is 4. Again, you ask how we get this. This is example. We will get away with that after we know how to handle all the situation. We'll replace everything by t, and this is estimated by sample, but this is just the first step. Okay, this is just imagine we know, we familiarize yourself with the notation. Okay, the sample size is 64. Okay, and sample means 5. Okay, do note that this depends on the sample. Okay, you collect. Okay, So the first thing we want to see is what is the null hypothesis. Here is mu is 4, okay? And we are doing one-sided test, it's right tail, so this is more than 4, okay? And just to remind you how you decide you're using the left side, left tail, right tail, or two tail, okay, or both tail. It really depends on the purpose, okay? It is not, it's given by the problem, okay? So decide what you would say in favor of the rejection, okay? Now the next thing is you can calculate what we call the test statistics, okay? Okay, we can work on this, it's fine. We can work on this directly, okay? But it is a customary work, we work on this, we normalize it, okay? Work on this one because it's easier, okay? So we know that this X bar, okay, will have a normal distribution, okay? Under the null will be the pen here, right? Oh, that pen, that's good. Oh, then I don't have to use it. That's good, that's good. So with mean 4, okay, will be sigma square 64 over the variance is 16 over root 64. Okay, so this is the bell shape you have here. Okay, this is X bar, the mean is here. Okay, so you would, if you want to see 4 and then you reject more than 4, that means that you would be say, if more than 4 enough, if it's sufficiently more than 4, right? Then you would say, okay, the 4 is unlikely, right? So when you say unlikely to this blue area, right, suppose this is sample mean you collect, right? If this sample mean you collect the right hand side, the blue area is less than say 5%, right? Then you reject, okay? Of course, you can do it directly, but it's customary. We would convert this into the Z space, okay? So you take 4 into 0, okay? And X bar will become X bar minus the mean, which is 4 here, okay? The 4 come from here, okay? And you divide by the standard deviation of this, right? 16 and then square root was 4 over 64. Oh, sorry. So sorry for that mistake. This is sigma square over n. So it's now is sigma over root n. So you convert it. This is what we call the test statistics. Right? Okay. And this X bar the data, which is 5 here. So we use 5. Let's change the number. It is 5. This is 5 now. Okay. So we have a 5 here. This is what we have. The data is 5. Okay. So turn out to be 1 over 4 over 6 is 8. So it's 2. Okay. So this is 2 here. Okay. So there are 2 ways to handle it. One is very obvious, very direct one is calculate this area. Okay. That means it's how far away this from the mean, right? And to do it, you can do this, right? Because on the right hand side of the 2 is this one. This one come from what? It's just 1 minus norm as this 2 true. Okay. To convince you this is the right thing, I just do the Excel. Okay, you get 0.208.
Okay, so let me do 1 minus norm this. Oh, sorry. This to true. Okay. So as I said, 1 minus norm. Why 1 minus? Because Excel only gives you the area on the left. Okay, the norm S. So 1 minus gives you the right, because overall is 1. Okay, so that's how you get the value, and we call this value p-value. Okay, you compare this p-value, compares it to alpha. Alpha is what you decide whether you allow the log happen, right? Time error, right? And this value is less than the 5%, because 0.002A is than 5. So it's enough away from 0. That means that your I think this is 4 here, right? For example, here this is 4, and what you get is 5, and 5 is far away from 4 in this example, okay? And this is 2, right? And this P is 0.028, right? It's less than 5, right? So that's why you would reject the null. You don't believe that it is going to be 4, okay? It must be more than 4, okay? You would think 4 is unlikely to be true, okay? We will say we reject H null at 5 significance level, okay? So we need to remember this statement. This is standard way to write. We reject the null at 5% or we don't reject, okay? Terminology is very little bit convoluted. You don't say we accept, but we say whether we reject or we don't reject, okay? And we will use a 5% at one level instead of 95% confidence region, just terminology, people use it in that way. And as I said, there are 2 other ways to do it, right? You can just use Excel to calculate this test statistics, right? Look at more than 2. But on the other hand, you can calculate what is the Z value, okay? The critical value, Z alpha, right? Z alpha is norm S inverse alpha, gives you the 1.64, right? This guy, how you get it? It just norm S inwards and 0.05. Okay, let me show you that's the case, but you should know it by now. This is not something terrible. It's norm dot S dot inward 0.05. So sorry, not 0.05. 0.05 is this side, so it's a 1 minus. So sorry, it should be 1 minus here, because alpha is the right hand side, so you have a left hand side. So this is 1 minus alpha. So I should put 195. Okay, so this should be the case. So let me correct this. It should be 0.95. Not 0.05, 0.95. Okay. So you can see the critical value here is 1.64. Okay, and your value 2 is further away from 0 than 1.64, so it's more extreme. So you reject the H null at 5% significance level. Okay, so that is important. Remember to say at what percent significance level. This is very important statement. Okay, and we will say reject or do not reject. Okay, so that would be the goal. I hope that I can convince you. You know the procedure, but don't worry, we'll do the same procedure for the left. Very simple procedure for both sides. Okay, then you are happy. Then you should be happy. Okay, don't worry about it. We'll be repeating ourselves several times. Okay. But before, is there any question? If there's no, is there a question? If no, then I just erase it and we go to do more, then you will be happier. So that is exactly the graph I drawn here. Now, the question is exactly opposite case, okay? So what we want is the null is A, alternative is less than, okay? When you use it is your consumer counsel, you don't worry about it's too much, but you care about too little, right? So the main idea is like this, right? Just to remind you. Okay, X bar under central limit theorem, this is what you see, right? Where is the center? Okay, under this X null, the center is at A. Okay, and you, as I said, we only worry about this is too small, so you just worry about there would be this is the area. If this small, it's called the rejection region, right? And we will put this rejection region, right? We put the alpha there, all right? And whether the X bar is in the green area, we reject. Outside the green area, we will not reject. Okay, so that is the main goal, okay? But we don't do it directly, we'll do it in a Z space, okay? What we're doing is instead of doing this, okay? We were doing that. But you know they're the same thing, right? So instead of this, we're doing this. This is Z. This is 0, okay? And you go down, okay? This number for alpha, right, will be negative Z alpha. Okay? So what you're doing is look at the X bar converted the test statistic, right? How we convert from the black graph to the, by this conversion, how we do it, right? Is X bar minus A over sigma over root n, okay? This is conversion from how you convert from the above to below, right? Because X bar has a normal distribution, right? With the mean A and variance sigma square over n. So you minus the A divided by the square root of the variance, which is sigma over root n. That will be giving us the Z table, right? So this area is the rejection area. Maybe I should use green color as well. Okay. So that is the main goal. Okay. If you collect the data, have a sample mean, okay? Do this minus A over sigma conversion. If that number we call test statistic is in the green area, then we'll say, oh, bye-bye, okay? Or you calculate the p-value, right? Look at the data, okay? And go to the data to see if it is here, right? Calculate area on the left, okay? If this pool area is less than alpha, you also reject, right? Because less than alpha means that it's also very far away, okay? So there are two ways to do it. Either you compare it with C alpha or calculate the p-value, okay? There are two different ways to do it. And okay, let's
This is just an illustration, but we'll go to the example, then you will see more. Okay, so don't worry about this graph. We'll give you more detail, but the same idea, right? If the z is less than the negative z alpha, then you reject just the mirror image of this, right? And if the p-value is so small, then you reject, because p-value means how far away from that. Okay, so let us do this again, the example. So I'm sorry that we are repeating ourselves, but sometimes it's the only way to learn. So we have a sample mean, okay? We know standardization 4, okay? So n is 64 here, okay? So it looks like this. Okay. And this is 4 here, okay? Just to remind you that this is normal, but this normal have a sigma, okay? Sigma in this is 4 over root n is 8. It's actually half, right? So the sigma is half for this guy. Now, what we're trying to say is, here is the procedure again is we look for the rejection region. This area is called the rejection region. Why? Because we're saying whether it is small. If it's very small, then we will say we don't accept it, right? So we want this rejection region, right? The size of this is alpha, okay? Of course, we can easily calculate this area because of computer nowadays, but we follow the tradition. We don't do this directly. We convert this to z, okay? Instead of this, okay? What we're doing is we convert it to the following, right? Z is here. Sorry, it's not dark enough. I use a darker color, darker tone. Z is here. Okay. And you convert it to 0. Okay. How you get from here to here, right, is x bar minus the mean, which is 4. Okay. And divided by 1/2 or 4 over root 64. Okay. And what we now have what is the sample mean we have is 3. Okay. So we're free. So we need to decide whether 3 is in the red rejection region or not. Okay. So if your data you get is 5, the sample mean is 5, then you can go home directly. Right? If the sample mean you get is 5, you can go home. If sample mean is 4, you can go home. But if sample mean is 3.9, then you have to do things. Okay, if sample mean 6, can you go home? Yes, you can go home, right? If 7, you go home. 10, you can go home. If 1, 2, or 3, anything below 4, you have to do something. Okay, you decide the distance from 4 is it far enough, okay, to allow us to reject it. Okay, and to do so, you can always do it on the x bar area, but we don't do that. We start looking at the z. Okay, so what we are doing is this one. If you convert this, right, this area, same thing, and this is going to be negative z alpha. Okay, and negative z alpha will be just right. This is alpha 5%, so we just we have already done it. So it's just the norm, this guy, the whole thing, just the norm as inward alpha. Okay. So it's turned out to be this number is 1.64. If we use alpha as 5%, negative 1.64, because on the left hand side is negative 1.64. Okay, so remember, you do the calculation, right? Your data turn out to be, okay, this is the rule there. So what you see is you get the data,
The data tells you it's free. Okay. Okay. Then you convert it to here. Okay. Which is -2. Okay. You know the critical value. Okay. Here is -1.64. Okay. So your -2 is even further away from 0 than the critical value. Okay. You pass the point of you within the region of rejection. So you reject the H null at 5% significance level. Or you can calculate the area of 2, -2, right? So how to calculate this value, right? Will be norm as this -2 true, right? Because it's less than or 2. Okay. So this one, I don't think I need to go over, but I just go over one small, right? Will be the norm this -2 true. Okay. But I hope that is not a big deal for you for now. Okay, so this is 0.02. So that's how you get this number. And this number is less than 5%, then you reject. Okay, so you can see it's rather the same boring technique again. Okay. So next week we will be doing we will do the sigma, then use the T, then the same procedure. So don't worry. If you don't get it right this time, next time you get it right. Okay. But before we let you go, we need to talk about the both tail. But you will see exactly the same procedure. Okay, that's nothing indeed. But before we go to the last example, any question? Okay. If no, then we go to the example again. So here, now there's a little bit complication when you talk about two-tail. Okay. Why is a little bit more complicated? The reason is following. X bar is here. You claim A is in the middle. Another null, this is the barrel like this, right? And you will not be happy if it is too big or too small, right? Too big or too small, you would be jumping up, right? So that means that, just like the very beginning example, okay? You wanted the middle one to be 1 minus alpha, right? So that means the rejection area on here will be alpha over 2. On this area will be alpha over 2. Okay. So this is the only difference between the one tail and two tail. The middle is still 1 minus alpha, but you both tail is alpha over 2. Okay. So and basically this is what you get, right? You convert it to the Z space. Okay. This becomes 0, right? And this green area is alpha over 2, and this green area is alpha over 2. Okay. This is Z alpha over 2. This is negative Z alpha over 2. Okay. So that would be the case. Okay. So if your X bar, okay, is within the red area, then you reject, right? There, or the red area, the rejection region. Okay. And again, the transformation to here, right? It's the same. X bar minus mu over sigma over root n. Okay. And when you transform this, then you also to the below graph, whether it's green area, you reject. Okay.
So the only one complication you have to be very careful. Okay, be very careful. Is what is the p-value? Okay, have to be very careful. The p-value. Okay, the p-value is like this. Okay, to make our life easier, suppose this is your x bar, right? And you convert it to somewhere here. Okay, so you convert somewhere here. Okay, and your p-value will be here. This red area times 2. Okay, the p-value will not be just the area on the left. You have to multiply by 2. Okay, the reason is you don't know which side. Okay, so you multiply by 2 because you don't know which side, right? Because it happened to be on the both sides, so that's why you multiply p by 2. The reason is you compare p-value with alpha over 2. Okay, so either you compare p with alpha 2 or you multiply p compared to alpha. You get what I'm doing here, because either you compare this area to alpha over 2 or you multiply this area 2 compared to alpha. And it's a convention that people multiply by 2. Okay, don't ask me why. This convention people call this p-value, right? I mean, you can also define it by half and compare to alpha over 2. And one of the explanation why we do it this way, because we don't know which side it will go, right? At the end, you go to one side, but it equally can be the other side, right? So philosophically, this is more looks better. Okay, so don't worry. Let me go over the example again. The last example we're doing, then you will not be too much concerned. So it's more it's pretty mechanical. Okay. Here, what we have is exactly almost the same question again. So we have x bar here. The sample mean, the population mean is 4 under this null. It's already here. Okay. So this is the data. The data tells us it is 3. Okay. So do you know that different from the one-tailed test? Unless your sample mean is 4, you can never go home. Okay. Before one-tailed, you can go home without doing. Maybe there's some case you don't have, you can go home. But this one, you can't go home. If not equal, you have to always do calculation, whether it's far away from 4 or not far away from 4. Okay, it's either side, right? Because both sides you can reject. So 3 you have to check. Okay. Now, remember, we want to see the rejection regions following, right? We just try to see the middle thing is 1 minus alpha, right? So we don't know which side it is, so that's why we would put this area is alpha over 2, and this area is alpha over 2. Okay, so we want to make sure that the two areas are symmetric on both sides, because we have no idea which side is more likely. So the unbiased, the natural way is to put alpha over 2 on the both sides. Okay. And as I said, we don't work on this one. Traditionally, we work on the other one, which is the Z1. Okay. Which 4 would become 0. Okay. And the red thing is still 1 minus alpha, okay? And we want this green, let's get more greener. This green area is alpha over 2, and this green area is also alpha over 2, okay? Without doing the calculation, you know this z, this is z alpha over 2, and this is negative z alpha over 2, okay? And now, look at the data here. We have 3, okay? This is the 3 here. And convert to here, what's this number? 3 will give us negative 2. How we get that? Is from this expression, right? 3 minus the 4. 4 is coming here. Okay? And over the sigma over root n, sigma is here. N is here. Okay, so that you negative 2. Okay, And finally, I want to, so sorry, I just over time a little bit. So how to calculate this guy or this guy, right? This guy is just alpha on the tail, okay, to this case, alpha on the right tail, right? So this is just the norm as inward. If 5%, right? So it's 2.5%. The right hand side 2.5, the other side is 97.5. Okay. So this will give you 1.96. I'm not going to show the Excel. I hope this is fine. You can show the, you can do the Excel. Okay. So this is 1.96, and this is negative 1.96. Okay. Then this is negative 2, so that's why it's more further than that, you reject. Okay. Other way around, you can calculate the 2. Okay. Will be the norm as this. Okay. Negative 2. Okay. This calculate the blue area. Okay. You multiply 2. Okay. Because 2 times the p-value. Okay. So can you calculate this? It's less than the 5%. So that's why you reject. Is that okay? Because negative 2 is here. On the left for negative 2 is this blue, dark blue area. Okay. It's the same. The norm 2, norm negative 2 is the standard thing. Of course, you have to put the true here. Okay. The only difference is we have multiplied by 2, okay, to compare. Is that clear? So I will be seeing you next week. Just remember your homework to be due to 10 days from now, not this Friday, those days under 10 days from now. And you will be also, you can start to think about your project. But too early, okay? It's only you have 40 days, so it's too early. But you can start to think about what data you want to get and so on and so forth. Okay, because some people ask me the project thing, but this project is just a longer homework, so don't worry too much. Okay, I will see you next week. If you have a question, I'm happy to answer.